Welcome back, Pre-Calc. Our objective for today is going to be to solve some more trig equations by hand and with the calculator. I'm going to force pause on your screen. You know what to do from here. All right, you don't need to write anything yet. I just want to kind of talk through the strategy. So again, our first thing we need to do is go ahead and isolate the trig expression, just like we did last time. But then what you'll notice for many of the questions today is that your domain is not going to be restricted from, say, 0 to 2 pi. You're just trying to find what's called the general solution. And remember, in that case, you're going to have an infinite number of solutions, right? Because, for example, there's an infinite number of times that sine of x is equal to 1/2, say, right? So we just get that wave, and it's going to cross y equals 1/2 an infinite number of times. So it's going to be really important here, because there's no way to write an infinite number of solutions, is what we'll do is once we get our solution, we can just add multiples of our period. So let's write down our periods so that we have that going forward as a memory. So what is the period of sine of x? Period of sine of x is 2 pi, and that is the same for cosine of x. Now what about tangent of x? Do you remember? So remember, tangent of x actually repeats every pi. Do you remember that your asymptotes went from negative pi over 2 to positive pi over 2? So tangent of x, I actually only have to check the first, or the top half of the unit circle, and then I'm just going to get repeats every pi, okay? So if I'm solving a question with sine of x in it, I'll find my initial solutions, and then I can just add multiples of 2 pi, okay? So what that looks like is we'll get our answer and then we'll go plus 2 pi n, where n is any integer, all right? All right, I'm going to force a pause on your screen. Can you copy example 1 for me? And then we're going to do this together. Okay, we are back. So we've got 3 cotangent squared x minus 1 is 0. I see that I'm not restricted to a particular interval. So first let's think about the period of cotangent or tangent. We said that was pi, right? Okay, so I only need to check the top half from 0 to pi on the unit circle because then I'm going to get repeat, okay? So remember, first thing we need to do is isolate the trig term. So I'm going to add 1 first, right? Get rid of the negative 1, and then divide by 3. And now I need to get rid of the square, right? So I need to square root both sides. Now remember, from Algebra 2, when you introduce a square root, you need plus or minus on the other side of the equation, right? So square root of 1 is 1, and then I'll have square root of 3. Okay, so now I need to figure out, again, for what angle is cotangent both positive or negative 1 over square root of 3. Well, let's draw our guide here. So remember, cotangent is x over y or y over x? Cotangent's x over y. So I can tell I'm going to be closer to the y-axis since square root of 3 is larger than 1. And I'm going to be in both quadrants 1 and 2, since I'm taking both positive and negative. So I'll be here and here, right? And remember, I don't have to check these 2 quadrants because of my period, okay? You can, and it's not wrong. You're just going to end up getting your solutions written down more than once, and then you'll have more work as well. So work smarter, not harder, right? All right, so my 2 angles, again, they're closer to the y-axis, so my denominator in radians should be what? Should be 3. And in quadrant 1, I have a numerator of just pi, and in quadrant 2, my numerator should be 1 less than my denominator, so 2 with your pi. So those are the first 2 solutions. Now they're going to repeat every pi because my period, I remember period is how long it takes till we get repetition. It's going to repeat every pi. So I'm going to go plus pi n. And again, n is an integer, so I'm going to go plus 1 pi, plus 2 pi, plus 3 pi. And I can also capture the negatives that way as well because an integer can be negative, and I'm going to do the same thing here. Okay, so that's what we call the general solution. All right, I'm going to force another pause on your screen. Will you please copy example 2 for me, and then we will do this together. Okay, so my little hint here was if you have more than one trig term, which you see I've got a trig term here and here, try factoring, okay? So kind of like when we were doing trig identities, let's think about that in algebra terms. So how you would see it in algebra would be like x squared minus x minus 2 equals 0, and we could factor that as x minus 2 x plus 1, right? And then we could set each factor equal to 0 and solve for x from there. So very similar, but instead of x, I have cosecant of z, okay? So I am going to factor this very similarly, but instead of x minus 2 and x plus 1, I'm going to have cosecant of z minus 2 and cosecant of z plus 1. Okay, now we can set each of these factors equal to 0. Okay, all right, so let's try that. So I'm going to take cosecant of z minus 2, set that equal to 0, and I'm going to take cosecant of z plus 1 and set that equal to 0. Okay, so let's work with that purple equation again. Isolate the trig term, so cosecant of z equals 2. Let's get this in a format we're a little bit more used to. What is the reciprocal of cosecant of z? Reciprocal of cosecant of z is sine, right? So I can take the reciprocal of this side as long as I take the reciprocal of the right side as well, right? What I do to one side, I have to do to the other. So now let's decide what z is there. So what's my angle? And notice, lucky us, we are restricted to one lap around the unit circle, okay? All right, so if sine is supposed to be 1/2, positive 1/2, what quadrants are we in? We're in quadrants 1 and 2 for sine to be 1/2, again, positive. And then are we closer to the x-axis, the y-axis, or right in between? We'll be closer to the x-axis in this case. So here and here, right? So in this case, z, if I'm closer to the x-axis, I have a denominator of 6. So I've got pi over 6 and 5 pi over 6 there. I'm not quite done because I need to come back and grab the solutions from that factor, right? So again, isolate. So I've got cosecant of z is -1. And don't let the z bother you. We're just using z's instead of x's or thetas. Okay, so now let's take the reciprocal of both sides. Reciprocal of the left side is sine of z. Reciprocal of the right side, well, when you flip -1, it's still -1, right? So thinking about the unit circle, I want the angle for which sine is -1. Well, again, sine's y, so that would be right there. So that angle is 270 degrees, but in radians, 3 pi over 2, right? So my final answers are these 3 angles. All right, I'm going to force a pause on your screen. Can you please copy example 3? And then we will work this one together. Okay, we're back. So it says find the general solution. So that's when you're going to have your plus, whatever n, and then state the solutions for n equals 1. Okay, so let's think about what is the period again for cosine? 2 pi. Okay, so one thing that's different here is that you've got your 3x instead of just an x in the argument, right? So think if we did not have the 3 there, we would want to see, okay, for what angles is cosine equal to 1/2? So what quadrants would we be in? We'd be in quadrants 1 and 4, because cosine's positive in 1 and 4, and we would be closer to the x-axis, the y-axis, or right in between. Closer to the y-axis, right, because I want the x-coordinate to only be 1/2. Okay, so if I didn't have the 3 there, I would say that x is equal to these 2 angles, 2 pi over 3 and 2 5 pi over 3, right? But I do have the x there, so that means I need the x here as well. Correct? So I need that whole angle, that whole inside piece, which is 3x, to be equal to pi over 3 and to 5 pi over 3. Okay? All right, now we do have the general solution, so what do I need to add there? We need to add plus 2 pi n to both of these. All right, we are almost there. If I want to get x by itself, we just need to divide by 3, right? So I'm going to divide here by 3, meaning dividing by 3 is the same as multiplying by what? By 1/3, right? So if I multiply everything by 1/3, let's see what we get here. So this gives me just x equals, distributing that 1/3, I get pi over 9 plus 2 pi n over 3. And here, the 3 and the 1/3 cancel, so I get just x equals 5 pi over 9 plus 2 pi n over 3. So that's my general solution. Okay, now it says state the solution for n equals 1. Okay, not a big deal. I'm going to make anywhere I see an n, so here and here, I'm going to make those 1s. Okay, so I have pi over 9 plus 2 pi times 1 over 3. And then 5 pi over 9 plus 2 pi times 1, so I don't need to write it, over 3. So let's simplify these. I need a common denominator, so let's multiply by 3 here. So that gives me 9 in the denominator, 6 in the numerator, so 7 pi over 9 here. Similarly here, multiply by 3. So add your numerators across now, you get 11 pi over 9 here, okay? So the blue is the general solution, and then the red is the particular solution for n is 1. All right, I'm going to leave you with example 4. I'm going to talk you through a bit of it, and I'd like for you to bring this to class. I'm first going to force a pause on your screen. Go ahead and copy that equation for me. Okay, so a couple things to note. This interval is really important, so we only want solutions between 0 and 3 pi. Those are x's. Now, this is solving using a graphing calculator, okay? So what I want you to do is in y1, if you're on an 84, or in line 1, if you're using Desmos, type that in, okay? And then in y2, type in just 1/2, or if you're in Desmos, you're going to type in y equals 1/2. Okay, and I want y1 to equal y2. So in terms of the graphs, I'm looking for what? I'm looking for their intersection. Now it's going to be really important that you set your interval, your x-min and your x-max appropriately so that you capture the correct solutions and only the correct solution. So for x-min, since we're going to come back to that interval, that should be 0, so your left value on your screen. Your x-max, your right value, is going to be 3 pi. Okay. Now for your y's, let's talk about that. y2, or y equals 1/2, is just a horizontal line through the y-axis at 1/2, right? So for y-min, why don't we go like -2 to +2, so we can be sure we capture that 1/2, but we don't get too far away that we can't see what's going on close to y equals 1/2. Okay, so find the intersections for me there, either using an 84 or Desmos, and then bring the answers to class, and we will see how you did. All right, bye, y'all.